This is the last video on similar shapes. I'm going to deal with similar volumes. We have two cuboids here which are similar, so I'm going to work out the length scale factor, enlargement. We can take any two sides. I'll take the 4 and the 8. So if it's enlargement, we're starting with the smaller and working to the larger shape. So 8 over 4 gives us a scale factor, a linear scale factor of 2. What I'm going to do now is work out the volume of shape 1, this one here. So volume is LBH, and that's 3 times 4 times 5. That's 12 times 5 is 60 units cubed. Let's just say 60 centimetres cubed. Now the volume of 2, this is shape 2 here, and again it's length times breadth times height. So it's 6 times 8 times 10. 6 8s are 48 times 10 is 480 cm cubed. Now the question is, how do we get from this 60 to this 480? Well, 480 divided by 60 is 8. So the volume scale factor is 8. And the question now is, how do we get from a length scale factor of 2 to a volume scale factor of 8? Well, the answer is that we cube. Which is to say that the volume scale factor is the length scale factor cubed, and that the length scale factor or linear scale factor is the cube root of the volume scale factor. So we have question example 1. We have 2 cylinders, and the base radius of the first cylinder is 3 centimeters, and the base radius of the second cylinder is 6 centimeters. Let's work out the volume of the second shape. So the first thing to do then is the linear scale factor. Enlargement, that's the scale factor that will take us from shape 1 to shape 2. Nice and simple. Final over initial, that's 6 over 3, and that's 2. So this linear scale factor is 2. Volume scale factor enlargement is the linear scale factor cubed, and that's 2 cubed, which is 8. So volume 2 is found by multiplying volume 1 by 8. So 8 times 10 gives us 80 centimeters cubed. Example 2, we're dealing with 2 cones. So let's work out the linear scale factor. Why don't we do reduction this time instead of enlargement? So if it's reduction, we're going from the larger shape to the smaller shape. The final then will be 2, and the initial will be 5. Now we can't do anything with that, 2 over 5. I suppose we could write it as 2 divided by 5 is 0.4. We can use either of those numbers, the fraction of the decimal. The volume scale factor And this is the length scale factor cubed. I'm going to use the fraction. Now, 2 cubed is, so we cube both parts, the top part and the bottom part, the numerator and the denominator. 2 cubed is 8, and 5 cubed is 125. So to get, so volume 1 then, we multiply volume 2 by 8 over 125. So that's 8,000 times 8 over 125. Calculator work. Gives us the answer 512 meters cubed. So example 3, the final example, what we have here is a question where we're given the volumes, but we're missing one of the lengths. So what we're going to do here is work out the volume scale factor. We can use reduction, since the first shape is the larger shape, the second shape is the smaller shape. Final over initial. So it's 8 over 27. Now, to get the length scale factor, what we're going to have to do is to find the cube root of the volume scale factor. So if you put that into your calculator, 8 divided by 27 equals, and then we take the cube root. Your calculator may give you the exact answer 2 over 3, or it may give you the decimal approximation 0.666 dot dot dot. You can use either one of those. You need to be reasonably accurate with this though. So remember, that's the reduction scale factor, so we're going from the larger shape to the smaller shape. V2 then, not V2, but the missing length is found by, so the linear scale factor is 2/3, so we'll multiply 2/3 by 6, and that gives us the answer 4 centimetres. That's how to use the volume scale factor to get a missing length.